Hey guys, today we're going to learn about linear approximations, which uses a tangent line based at x equals a to approximate f of x for x near a using a formula called the linearization formula. So this is the linearization formula here on the right, and what this is basically saying is that f of x is congruent to L of x for x near a. So this function is pretty congruent to 1 over 2, where a equals 2. So the first step to apply this formula is we need to define f of x. So we look at what's given and say, if we define f of x as 1 over x, then x would equal 2.02, and then a would equal the closest whole number to x, which is going to be 2. So let's rewrite the linearization formula and see how we can plug those x and a values into this formula. So first we'll start with f prime of a, or in other words, f prime of 2 times x, which is 2.02, minus a, which is 2, plus f of a, which is f of 2. And that's how you plug in the x and a values into L of x. Now all that's left to do is simplify these terms. F prime of 2 is another way of saying the derivative with respect to x of f of x at x equals 2. So in other words, we'll use the power rule to define the first derivative of 1 over x as negative 1 over x squared. And plugging in 2.02, that's about 1/4. Then defining f of 2, which is just 1 over x with x equals 2.02 plugged in, which is 1 over 2. And then simplifying that further, we have L of x equals negative 1/4 times 0.02 plus 1/2. So in other words, our approximation is 0.495. But if we plug in 1 over 2.02 into our calculators, we would get 0.4950495. And that is sufficiently close to what our approximation is. So that checks off our approximation as being accurate. But to analyze that difference a little bit further, we can find the error in approximation, which is defined as the absolute value of L of x minus f of x, or in other words, the approximate value minus the actual value. So that's going to be 0.495 minus 0.4950495, which the absolute value of that gives us just 0.0000495, or a percent error of just 1%. So that's how to use the linearization formula to get your linear approximations. I hope that was helpful. Good luck, everybody, on your exams. Please subscribe, and I'll see you in the next one.